In this question, we have a situation in which a drug is given for a certain medical condition. The dosage is 260 milligrams and it's given every 4 hours. And the drug has a half-life in the body of 4 hours as well. Which means that each time a new dose is administered, half of everything that was still remaining in the body is still there. And our question is, what is the steady state long-term amount of drug in the body? This is an important thing for doctors to keep in mind, so that you may underprescribe at the beginning. The initial dose isn't actually what's healthy and therapeutic, because there will be a buildup in the body over time. So our question is, how much will be in the body after a long-term amount of taking the drug? So the idea here is that the initial amount, how much do we start with? We start with 260. That's how much we'll have it right after the first dose. After the second dose, we're going to have the second dose of 260, and we're going to have 1/2 of the 260 that was around from the initial dose. Right, so this is the new dose. This is half of what we already had. After the third dose, we'll have the new dose, and we're going to have 1/2 of this stuff. That's the stuff that we had in the body after the second. So that's going to be 1/2 of 260 plus 1/2 times 1/2 of 260. This should remind you of the process that we use to develop the whole formula, A over 1 minus R. This is exactly the same thing. So this is 260 plus 1/2 of 260 plus 1/2 squared of 260. The next one will be the next dose plus 1/2 of all of this stuff. But 1/2 of all of this stuff is 1/2 of 260 plus 1/2 squared of 260 plus 1/2 cubed of 260. And we can see the formula. If we go all the way down to infinity, we get an infinite series. This will be sum of 260 times 1/2 raised to the power of k, where k starts at 0, because the 1/2 to the 0 makes 1, and that's our first dose, going to infinity. That's fine, so we can write the sum like that in summation notation. This is actually better for finding A and R. A is 260, the very first term. R is the 1/2, because I multiply by 1/2 each time I go to the next term. So the final value of the series will be A over 1 minus R, which is 260 over 1 minus 1/2. And that's the amount of the drug that will be in the body after taking this dosage long term. And so let's take another look at how we could have answered this problem using some of the ideas from a previous section. Remember that we had 260 milligrams given every 4 hours, and it has a half-life of 4 hours. So we can think about this as saying the amount in the body after dose N is given by 260, that's the new dose that we're given, plus 1/2 of however much we had in the body before, AN minus 1. And so we'll think about this as a recursively defined sequence. And remember that we came up with a very quick way of figuring out what the limit is of a sequence when it's defined like this. If we take the limit of both sides as n goes to infinity, remember that the limit of AN is exactly the same as the limit of AN minus 1, because this is just one term behind, and at infinity they are the same. So we'll think about this as x, and this is the same as 260 plus 1/2 x. With the 260, the limit of 260 is 260, the 1/2 also comes out front. If we bring this over to the left by subtracting 1/2 from both sides, I get 1/2 x is 260 multiplied by 2, and I get 520. And this is the limit of the long-term steady state amount of drug that will be in the body.